Welcome to 8.4, Angular Variables and Tangential Variables. So we're mainly going to be focusing on these three tangential equations. Tangential velocity equals radius times angular velocity, tangential acceleration equals radius times angular acceleration, and s equals r times theta. So they each affect each other. For example, to make an angular speed increase, you're going to have to also increase its tangential speed. Also, you can see that in figure 8.9, the tangential velocity of each skater is represented by an arrow that's tangent to each arc. So you already know that since there's other factors that come into it when you're looking for tangential velocity, you also have to consider the radial side, so the x or the theta of it, to be able to find your tangential velocity. Tangential velocity, though, only refers to the motion of a single point of an object, versus angular, which describes the motion of the entire object. So here I drew below. The circle is moving forward, so it's linear, it's tangential, but you also have to consider the fact that it's rotating itself as well, so that's the angular side of it, but they're separate. So in 8.11, it shows you that points 1 and 2 are rotating on the same angular speed and acceleration, but they have different tangential speeds and accelerations. Okay. So the blade of a lawnmower is rotating at an angular speed of 17 revolutions per second. The tangential speed of the outer edge of the blade is 32 meters per second. What is the radius of the blade? So they're giving us two units, revolutions per second and meters per second, so we have to write them down. So angular velocity is 17 revolutions per second and tangential velocity is 32 meters per second. And like I said before, we can use one of the three equations I gave you. So tangential velocity equals radius times angular velocity. So you divide those and you end up getting, you can see that it would be radius would be radius would be tangential velocity over angular velocity. So that would be 32 over 17, and it would give us radius as 1.88. But as I said before, they gave it to us both in revolutions and meters per second, so we have to change it because now we have it in radians. So 1.88 radians, and then we would multiply it by 2 pi radian to get it into 1 revolution to find the radius of it, and it would give us 0.30 in meters. Okay, so an auto race takes place on a circular track. A car completes one lap in a time of 18.9 seconds with an average tangential speed of 42.6 meters per second. Find the average angular speed and the radius of the track. So, 1 lap, 1 revolutions, 2 pi radians. We put that down as our distance. Time is 18.9 seconds. Tangential velocity is 42.6 meters per second. So they're asking us for the first A, angular speed. So we know that velocity is distance over time, so we can also say that angular velocity is theta over time. So we already know our distance because it's 2 pi, and then we would put it over 18.9, which is our time, and we'd have the angular speed of 0.332 radians per second. Now we go to part B, the radius of the track. So we can also use one of the three equations I gave you in the beginning, which is tangential velocity equals radius times angular velocity. We cancel out the angular, be able to find the radius, so it would be tangential velocity over angular, which would give 42.6, like one of the givens they gave us, and then we divide it by the one that we found in part A, which was 0.332, and then we'd have our radius as 128 meters. In 9.5 seconds, a fisherman winds 2.6 meters of a fishing line onto a reel whose radius is 3.0 centimeters. And then what's important, what I like to do is highlight all the givens to remember them and write them down. Anyways, whose radius is 3.0 centimeters, assumed to be constant as an approximation. The line is being reeled in at a constant speed. Determine the angular speed of the reel. So we have time as 9.5 seconds, the distance is 2.6 meters, the radius is 3 centimeters, to which we'd put into meters, which would be 0.03 meters, and we know that it's constant, that the acceleration is at a constant speed. So, the velocity is at a constant speed, so we already know that the acceleration is going to be 0, and they're asking us for W. So if we know velocity is distance over time, we could put 2.6 divided by 9.5 to get the velocity of 0.27 meters per second, and that's linear. So since we already have the linear or the tangential velocity, we can do the Vt equals W times R. So we would divide that by R to be able to get W equals V over R, which is right here. And then we would divide 0.27 divided by 0.03, and then we would get 9 radians per second as our angular speed. A string trimmer is a tool for cutting grass and weeds. It utilizes a length of nylon string that rotates about an axis perpendicular to the one end of the string. The string rotates at an angular speed of 47 revolutions per second, and its tip has a tangential speed of 54 meters per second. What is the length of the rotating string? Okay, write down the givens. The angular velocity is 47 revolutions per second, and the tangential velocity is 54 meters per second. So we already know that we're going to have to convert revolutions to radians, as I wrote here. So we would put 47 revolutions per second, and then we would put 1 revolution equals 2 pi radian to be able to have it as 295.31 radians per second. And we also know one of the equations that I gave you before, which is tangential velocity equals radius times angular velocity. And you would divide by angular velocity by each side to be able to have radius equals tangential velocity over angular velocity. So then we would use the tangential velocity, 54 meters per second, divided by our angular velocity in radians, which is 295.31 radians per second, and then we would get 0.18 meters. And that's it really. Whenever they're going to ask you for anything tangential, you know that you would have to multiply it by the radius, and you would have to multiply it by its angular version. So you would have to use these equations to be able to find the answer, and then once you know those, you're good.